Hi guys, welcome back. So today we are going to start our unit on radical expressions. So let's go ahead and do this. Okay, so this symbol right here, this bad boy is called a radical. That is the radical symbol. So back in the day, we had simplified something that looks like this. Okay, this is a way that we would typically see it, but I'm going to just write it a little bit different. Okay, so then in this case we're going to read this as square root of 9. Okay, so what I want to point out is this. I'm going to give a little left to this number right here, the 2. Okay, so the symbol right here is a radical sign. The number that fits in that nook is called the index. Sometimes the index is written explicitly, sometimes it is not. Okay, now when we have the square root of 9, the thing is, when the index is 2, we typically don't write it. Okay, so you'll pretty much see it like this. Okay, now someone asks, well, how do I know if it's square root of 9, cube root of 9, fourth root of 9? So pretty much, if the index is 3 or higher, the only way we're gonna know is if we have a number written in that nook. Okay, and if it's blank, then it's implied that the index or root is 2. Okay, fantastic. So just to recap, the symbol right here is called the radical sign. The number that fits in that nook is called the index. If you see it written explicitly, okay, then that number is the index. In this case, it's 3. If it's blank, then that's implied that the index or root is 2. Okay, fantastic. So let's go ahead, open it up, or continue with the definition of the nth root. Okay, so I'm gonna just read it and then I'll break it down. Okay, so it says if the nth root of a equals b, then you can read then b to the n equals a. Okay, what this is saying is this. If this is your question, nth root of a, and if that's your answer, what has to hold true, or what do you have to do to check it? Okay, so to check it, you're gonna take your answer, raise it to some power, which is the index, and that needs to give you back the radicand. Okay, that's like a lot of words, so let me break it down with stuff that we have seen many moons ago. Okay, so if I asked you this question quick, what's the square root of 9? You're like, oh, I'm a genius. Square root of 9 equals 3. But then I asked you to check it, to confirm it. To check it, what has to hold true? We have to take our answer, raise it to whatever the index is, and that has to give us back our radicand. In this case, it has to give us back the number that we're square rooting. So to check it, we're going to take our answer, raise it to whatever that index is. Again, if it's left blank, then it's implied that the index or root is 2. Hence, we read it as square root of. Okay, so we take our answer, raise it to some power. What power? Whatever the index is. And then that needs to give us the radicand. So in this case, whatever we're square rooting. Okay, I think I forgot to say that one. So radicand is the number that's under the radical sign. My mistake. Okay, so I know that you know that the square of 3, or 3 squared equals 9. So to answer my question, did we simplify the square root of 9 correct? And in this case, we did. Why? Because our answer raised to that index gives us back that radicand. Okay, so that's what it's saying. Okay, if the nth root of a equals b, what has to hold true? Our answer raised to the index needs to give us back that radicand. Okay, so now let's go ahead, throw in more fun words. Okay, so whenever possible, I like to go straight to the examples, but sometimes I gotta say all those words and then follow it with the examples. Okay, so we have 3 case scenarios. Let's go ahead, open it up with case 1. So it says if the index is even and the radicand is non-negative, then okay, too much information. Okay, so we have some radical. That's nice. Okay, if the index is even. Okay, so I'm just gonna stick with square root. Okay, so I'll leave it blank. And the radicand is non-negative, so whatever we're square rooting is not a negative number. So let's just say 25. I'm gonna put another spicier problem. I'll put square root of 25, but I'll put a negative sign in front of it. Okay, so we have a lot of cool words. I'm just gonna go ahead, simplify this, and then go back to the cool words. Okay, but I just want to illustrate that I set this up however I want to talk about. index is even, okay, so we have square roots. You know, if you want to highlight the index, go for it, but if you don't need it, then I don't need it. Okay, we have an even index. Radicand is not negative, okay, so our 25s are not negative. I'm just going to simplify this and come back to the words. So I'm like, quick, what's the square root of 25? We're like, square root of 25 is 5. Okay, if you wanted to check it, our answer raised to that index needs to give us back that radicand, and it does. Now, what if I have a negative sign in front of the radical? It's no big deal, okay? So pretty much I want to know what's the opposite, okay? So we're just going to take the square root of 25, which is 5, and then we're going to go ahead and bring down the negative, okay? So now let me go ahead and talk about the words. Well, let me box my answer, force a habit. So it says, if we have an even index and a non-negative radicand, if we are asked to find the nth root of a, then we want the positive root. But if we have a negative nth root of a, then we're looking at the negative root. Okay, so what I want to point out is this. Sometimes students say, oh, square root of 25 is plus or minus 5, you know, but that's like actually a lie. Okay, square root of 25 is just 5. It's not plus or minus 5. What this is saying in short words is pretty much this. If I don't have a negative sign in front of the radical, then I'm looking for the principal root or the positive root, okay? But if I have a negative sign in front of the radical, then I'm looking for the negative root, okay? But if you want to avoid all these words, just break it down and then, take the square root of whatever you can. And if there's a negative sign, just think about it. I got to bring down the rest of the problem. Okay, I said it. Cool. So that's case 1. All right. Case 2, okay, if the index is even, okay, so if we have an even index and the radicand is negative, okay, so I don't want to make this spicier than needed, so I'll just stick with square roots, okay. If we have an even index, okay, so I'll leave it blank so we know that the index is 2, okay, and the radicand is negative, okay, I'll just say negative 25, okay. What is going on? If we have an even index and a negative radicand, then whatever we have in the nth root of a, or our problem, does not represent a real number. Okay, so we got square root of negative 25. Okay, so I'm gonna go ahead and cheat because I'm supposed to do these by hand, but I'm gonna punch it into my calculator. We got square root of negative 25, then we hit enter, and I can't even cheat because my calculator doesn't know the answer. Okay, it gives me error. Okay, so the moral of the story is I gotta keep my cool. If we have an even index and we have a negative radicand, then what is going on? And that means that the whole radical simplifies to a non-real number. Okay, so not a real number. Okay, so we can simplify this, but we're not at the section where we can simplify non-real numbers. For now, if we come across a non-real number, we're just like, ooh, not a real number, and then that's it. Okay, in the later section, we're like, oh man, we got a non-real number, but it's cool. Okay, we're gonna talk about how to simplify them. Okay, so now let me put another example. What if I have 4th root of negative 25? Now I'm like, okay, what does that simplify to? So I'm like, okay, first things first, what's the index? Is the index odd or even? We haven't talked about odd just yet. Oh, the index is even. I got an even index, okay? If we have an even index, there's no way around it. The radicand has to be positive or else. In this case, the radicand is once again not positive. So if we have an even index, then the radicand has to be positive. And if it's not, then guess what? The whole expression once again will simplify to a non-real number. But again, for now we say not a real number. In a later section, we'll talk about how to simplify those non-real numbers. All right, third case scenario. So it says if the index is odd, then there is I should circle it to keep consistent. Okay, if the index is odd, then there is exactly one real nth root of a. Okay, that's like a lot of words. Okay, so let me just break it down for you. So I'm gonna put cube root of 8 and cube root of negative 8. Okay, so what I want to point out is this: if the index is even, make sure that your radicand is positive. I'm supposed to say non-negative, okay? But yeah, make sure your radicand is positive. If it is, you have the green light to simplify it. If you have an even index and your radicand is not positive or is negative, then you just go straight to not a real number, okay? But now this is the beauty. If the index is odd, you don't have to worry about, oh man, I gotta make sure my radicand is positive. If the index is odd, you know, you can simplify the radical regardless if the radicand is positive or negative, okay? So cube root of 8, I'm just gonna take a wild guess. I think it's 2. Okay, if I wanted to check it, what are we gonna do? We're gonna take our answer, raise it to the power equal to the index, which is 8, and then confirm. It gives us back that radicand. Okay, and in this case the 2 cubed is 8, so we check this. I should put CK for check. Okay, cube root of negative 8, I'm gonna take a wild guess and just say that's negative 2. Okay, so to check it, how are we gonna do it? So let me put CK for check. We're gonna take our answer, raise it to a power equal to the index, and then confirm. It gives us the radicand. And in this case, negative 2 to the 3rd power gives us negative 8. Cool. All right. So let's go ahead, toss in a couple of more meanings, and then we'll do a handful of problems, and then we're out. Okay. So it says the meaning of square root of a squared. Okay, I'm going to just say it and then I'll try to break it down for you in a bit. Okay, so it says for any real number, square root of a squared. You know, most of the time I just put a, but we are not told that that a represents a positive real number. So we have to say that it equals absolute value of a. Why do we need the absolute value? Well, that's because we need to ensure that the radicand is positive. Okay, so let's look at this. Overall, what's the meaning of nth root of a to the n? Okay, so we have 2 case scenarios. So I know you can read it, but I want to write it with you. Okay, nth root of a to the n. Okay, this is how it's going to go down. Case 1, what happens if the index is even? Case 2, what happens if the index is odd? Okay, so I'm gonna fill you in on the secret. Okay, if the index is n, let me go ahead and zoom in. Okay, index is n, power is n, they're gonna go ahead and do each other, and that's gonna leave us with the leftover radicand, okay, which is a. But the question is, do I need an absolute value? Yes or no? Okay, if the index is even, then we gotta throw in an absolute value. Why? Because if the index is even, we have to make sure we're square rooting positive numbers. Okay, or the radicands are positive, whether it's 4th root or square root, whatever. Okay, so when the index is even, get your answer, toss in the absolute value. Now, what if we have nth root of a to the n, and we're gonna look at the case where the index is odd? Okay, well, same speech, but not really. So I'm like, index is n, power is n. They undo each other because they're the same, and that will leave us with a. But the question is, do I have to toss in that absolute value? And the answer is no. Why not? Well, that's because when the index is odd, we don't have to make sure that the radicand is positive. Okay, so that's it. Okay, so do what you gotta do. Cancel, toss in absolute value if we have even index, and if we have an odd index, you're good to go. Okay, let's go ahead, do these set of problems. So we have simplify the following radical expressions. We have our problem right here. For some weird reason, I wrote it over. So I'm like, okay, index is 6, power is 6. They're gonna undo each other, and then that will leave us just with the radicand of negative 7. But my question is, do I gotta toss in the absolute value? And in this case we do, because the index is even. Okay, so it's gonna give us absolute value of negative 7. Why do we need the absolute value? Absolute value is required when you have an even index. Why? Because that's gonna be the only way that we can ensure that our radicand is positive. Okay, and then I know that you know that the absolute value of negative 7 simplifies to positive 7, so we're good. Okay, one problem down, one more to go. Problem B, we have 5th root of negative 8 raised to the 5th power. So let me go ahead, highlight if the index is even, or odd. In this case, the index is odd, so that makes me happy because I don't have to worry about those absolute values. So I'm like, index is 5, power is 5, they're the same, so they undo each other, and that will leave us with the radicand of -8. Cool. So we're going to do a couple more problems. Well, I lie, it's not really a couple, that's just how I speak. We're going to do a handful of more problems. So go ahead, continue writing. Go write down problem number C. I just have a typed up page because I wanted to make it look pretty. All right. So same speech, same direction. So simplify the following radical expression. So problem C, because we just knocked out A and B. So we have 4th root of -2 raised to the 4th power. We're gonna do this 2 ways, okay? I'm gonna do it the keep your cool way, and then the remember the rule way, okay? The keep my cool way is just code for do it however you can. Okay, so for me, I'm just gonna evaluate. Okay, -2 to the 4th power with a little magic. That's supposed to be a break. Sorry, -2 times -2 times -2 times -2 gives us 16, positive 16. And then at this point, you have some options. You can either generally evaluate 4th root of 16, or you can just show yourself some work. It's your test, so do what you gotta do. 4th root of 16, I believe that gives us 2. And if we wanted to check it, I'm not gonna write it out. Our answer raised to the index needs to give us back that radicand. And in this case, 2 to the 4th power gives us 16. But the question is, you know what? I don't have that practice with 4th roots, okay? I have practice with square roots, but I don't have that practice with 4th roots. Well, you don't have to memorize these things, okay? So like understand as much as you can and then memorize what you really have to. So I'm gonna give you a workaround. If the numbers don't come to you, then just prime factor this bad boy. So we're gonna prime factor the 16. So let me do it as a thinking area. So we branch it out. 16 is the same as 4 times 4. Branch out 4, and that will give us 2 times 2. Branch out 4, and that will give us 2 times 2. So the moral of this story is that 16 is the same as 2 to the 1, 2, 3, 4th power. Okay, so we're gonna write this as 4th root of 2 to the 4th power. Yeah, I'm not nervous, you're nervous. Fantastic. And then at this point, I'm crossing my fingers and I'm hoping that the index and the power are the same, and they are. Okay, so we're gonna undo each other, and that will leave us with the radicand of 2. Okay, so do it however you can. So we're gonna do this problem one more time. Okay, so we're gonna call this C2. So we have, where am I? 4th root of -2 to the 4th power. Cool. Now the question is, what if we didn't want to do all of this? What if we just wanted to apply the definition of nth root of a to the n? Okay, so nth root of a to the n. So we know that the index and the power will undo each other. Okay, but we're gonna have 2 case scenarios. One case where the answer is a with an absolute value, and case 2 just a without the absolute value. Okay, if the index is even, we gotta toss in the absolute value to ensure that our radicand is not negative. But if the index is odd, that's it. Okay, absolute value not required, because for odd index we can take for the odd index it's okay if the radicand is negative. Okay, I think I said too much. So let's do this. So I'm like, okay, 4th root of -2 raised to the 4th power. Okay, let's go ahead and do this. So the index is even. So that means that, I don't know why I'm tongue-tied, sorry. So even if index is even, so let's go ahead and make sure that we have an absolute value in our answer. Index is 4, power is 4, they undo each other. So that will leave us with the radicand of -2. But because we have an even index, we have to toss that inside the absolute value to ensure that we have a non-negative radicand. Okay, absolute value of -2 is +2. So that's it. Okay, so we get the same answer no matter what. Okay, I'm gonna try to say these without so many words. Okay, let's go ahead. Where am I? Problem D. Problem D, we have 4th root of negative 16. Okay, fourth root of negative 16. So I feel like I could answer, because we got fourth root of positive 16. But in this case, I'm going to pay special attention to the index. Is it even? Is it odd? In this case, our index is even, so we got to make sure that the radicand is not negative. Okay, so I'm just going to say has to say positive. Has to be positive. Again, I'm supposed to say it's non-negative, but that's just how I speak. Okay, so the moral of the story is this: if we have an even index and a negative radicand, then this is going to simplify to a non-real number, so not a real number. So we're going to leave it like this because we're not in the section where we simplify non-real numbers. Okay, problem E, where am I? So we have, where am I? We have negative cube root of 27. Okay, negative cube root of 27. Okay, so let's do this. So first thing, I'm going to give a little bit love to highlight if the index is odd or even. Our index is odd, so that means that who cares what the radicand looks like? It could be positive or negative. So I'm like, what's the cube root of 27? Assuming that you just have these numbers memorized, I'm going to go straight to answer, and then we're going to do it again, break it down by writing the number as a product of prime factors. Cube root of 27, I believe it's 3, and if you wanted to check it, 3 raised to the index needs to give us the radicand, and 3 to the third power does give us 27, but in this case we are looking for that negative root, or in English, bring down the rest of the problem. Let's go ahead and do this problem one more time. Negative cube root of 27. Again, memorize what you have to, but digest as much as you can. Okay, so if we don't want to memorize these things, let's just go ahead and write 27 as a product of prime factors. When we branch it out, 27 is the same as 9 times 3. When we branch out 9, that will give us 3 times 3. So the moral of this story is that 27 is the same as 3 to the third power. And in this case, I'm like, look, how exciting. Index is 3, power is 3. They're the same, so they undo each other. And that will leave us just with the radicand of 3. But then we got to bring down the rest of the problem, which is negative. So do it however you like. Okay, we got a few more and then we're out. Problem F. Problem F, we have negative cube root of negative 64. Okay. So this one is out of my comfort zone, so let's go ahead and do this. Okay, so I'm just going to do this by inspection. Okay, so index is 3. It will be nice if I can write negative 64 as a power of 3. So I'm thinking like 1 to the third, 2 to the third, 3 to the third, 4 to the third. Someone with the calculator, 4 to the third gives us 64. But in this case, we're going to write it as negative 4 raised to the third power. Okay, negative 4 raised to the third power will give us that negative 64. Why did I write negative 64 as a power of 3? Well, that's because I was looking for some power of 3. Okay, so we have cube root of that, and then we have a negative sign in front. So in this case, same speech. Index is 3, power is 3. The numbers are the same, so they undo each other. And that will leave us with the radicand of negative 4. But we got to bring down the rest of that problem, so that negative sign. If you need a parenthesis to separate these things, go for it. If you don't need that visual separator, then I don't need it. Opposite of negative 4 is positive 4. So the moral of this story is that negative cube root of negative 64 simplifies to 4. Fantastic. So we got 2 more. I just counted, and then we're out. G. G, we have, let me write down the fraction first. Okay, so the fraction is going to be the radicand, 81 over 16. We want the fourth root of this. Okay, fourth root of this fraction, and then we'll toss in a negative sign in front. Okay, so whenever the radicand is a fraction, I like to put the fraction first, because if I put the radical first, I never do it high enough. Okay, so this is out of my comfort zone, but we got this. So the index is 4, and it would be nice if we had a power of 4 inside. So let me see if we can write 81/16 as a power of 4. We'll do it one at a time. So 81, can I write this as the power of 4? I don't have that memorized, so we'll do it by inspection. 1 to the 4th power, 2 to the 4th power, 3 to the 4th power. People with the calculator, 3 to the 4th power gives us 81. Okay, so 81, we're going to write it as 3 to the 4th power. 16, can I write it as a power of 4? You know my speech, we do it by inspection. 1 to the 4th, 2 to the 4th, and 2 to the 4th power gives us 16. So the question is, could we write 81/16 as a power of 4? And the answer is yes, because we can write it as the 4th power of 3/2. Let's bring down the rest of the problem. Okay, so we want to take the 4th root of this bad boy, and then we have a negative front. So the question is, can we cancel things out? We sure can. Index is 4, power is 4, the numbers are the same, so they undo each other, and that will leave us with the radicand of 3/2. And then we'll bring down the rest of the problem. Okay, so we're looking for the negative root. Fantastic. Final problem of the day. Where am I? Problem H. So we have cube root of negative 0.125. Okay, so this is where me and your book fight, because most of the time I'm expected to just spit out the answer, but for me it's very difficult to do so. I'm not a big fan of guessing or memorizing things, so I'm going to give you a workaround. So by some miracle you can go straight to answer because you see things, but I really don't. So with your permission, we're going to write the radicand as a fraction. So the numerator will be 125. And in terms of the denominator, well, we'll just highlight the place value of the 5. Tenths, hundredths, thousands. So we have some thousands. So 1, 2, 3. Cool. And then we have a negative sign in front, and we want the cube root. Okay, so whether we have it in fraction form or in decimal form, they're both read as negative 125 thousandths. Fantastic. So I'm gonna ask myself, do I have the green light to proceed? Index is odd, so we don't have to worry about our radicand can't be negative. Index is 3. It would be nice if I can write this fraction as a power of 3. So I'm all about thinking positive. So let me go ahead and put my something to the 3rd power. 125, can I write it as a power of 3? I don't know, so I'll do it by inspection. 1 to the 3rd, 2 to the 3rd, 2 to the 3rd, until we get to 5. Okay, so 125 is a perfect cube because it is the cube of 5. So we're going to write this as 5 raised to the 3rd power. Can I write 1000 as a power of 3? For the purpose of time, we're just going to say yes, 10. Okay, 1000 is a perfect cube because it's the cube of 10. Now, someone asked me, shouldn't we have reduced this fraction? Yeah, but you know what? These numbers are out of my comfort zone, so it's just easier for me to go straight to power of 3. But if you want to reduce, go for it without a calculator though. Okay, let's bring down the rest of our problem. So 5 tenths raised to the 3rd power will give us 125 over 1000, but it's not going to give us negative, so it's actually negative 5 tenths raised to the 3rd power, and that will give us the negative radicand. Okay, let me bring down the rest of the problem. Cube root of that. So at this point, now that we have that power of 3, you can reduce now or reduce later. It's a personal choice. I'll reduce later. So now to simplify, I'm like, are these numbers the same? They sure are. Index is 3, power is 3. They're the same, so they undo each other, and that will leave you with the radicand of negative 5 tenths. Take your time and reduce it. So I'm going to go ahead old school reduce, meaning I'm not going to use the cross canceling notation. So in this case, top and bottom, or numerator and denominator, have a common factor of 5. So when we reduce it by 5, that will give us negative 1 over 2. Okay, and of course, if you look at the book, because the radicand was in decimal form, they expect you to write it in decimal form. I really don't care. Okay, so you can always write your answers in decimal form or fraction form. It's fine. If you write your answer as a decimal though, please make sure you don't round it unless you're asked to. Okay guys, that's my time. Thanks.